What are mass and gravity really? What if you stop treating them as mysterious labels and start asking what they look like underneath? In the energy filament theory, they are not two independent forces of nature at all. They are simply the way an underlying energy sea gets pinched, tightened and slopped when particles form inside it. Imagine the whole universe as a gigantic stretchy sheet that can be pulled tight in some regions and left looser in others. A particle is not a little marble dropped on top of that sheet. It is a place where the sheet itself has been gathered up and knotted into a bump. You cannot make that bump out of nothing. You have to pull fabric in from around it, drag nearby areas towards the center and lock it into a small knot. The moment you do that, three things happen at once. First, you tighten the fabric around the knot. The bigger or more intricate the knot, the bigger the ring of fabric it has stolen from, and the more that ring has to stretch to keep supporting it. The knot and the nearby sheet become one coupled object. Change one and you inevitably change the other. In this picture, every particle is such a knot of filament in the energy sea, and its mere existence rewrites how tight or loose its surroundings are. Second, that uneven tightness produces slopes in the sheet, and those slopes are what we experience as gravity. The universe does not have a built-in up or down. It has places where the sea is more relaxed and places where it is more strained. And it has directions where the sheet is rough and tangled versus directions where its textures are aligned and smooth. A tension slope runs from loose towards tight, and a texture slope runs from disordered patterns toward well-lined up ones. If you drop an apple near the earth, you are really placing it on a patch of fabric that has been pulled into a deep, tight basin and combed into preferred directions by the earth's mass. When you let go, the apple simply slides along the combined slope toward the region where the fabric is already tighter and its threads are already better aligned. No invisible hand reaches out from the planet. The apple is just following the easiest path in the sheet. On a small scale, that path looks like down. On a large scale, we call it gravity. Third, the difficulty of sliding the knots sideways through the sheet is what we call mass. If you try to drag your bump to a new location, you cannot just grab the peak and yank. You must also rearrange the whole ring of stretched fabric around it, loosening some regions and tightening others. The more the sheet was stretched to support the knots, and the wider the area that is affected, the more work you must do. That total effort to rewrite the sheet is the particle's inertial mass. A neutrino is like a tiny dimple that barely tightens the fabric at all. The sheet around it is almost as relaxed as before, so you can slide it with very little resistance. And we say it has a tiny mass. A proton is more like a complicated knot of three interlocked loops that drags a big patch of the sheet into a deep, tight well and imprints strong directional textures. To move it, you have to haul that whole tight, combed region with it, so it strongly resists acceleration, and we measure that as a large mass. It helps to say it in a few clean lines. A particle is a knot in the universe's fabric, not a bead sitting on top of it. Knots tighten the fabric and combs its texture, and everything sliding down the resulting slopes is what we see as gravity. The more fiercely a knot grips and organizes the fabric around it, the harder it is to budge and the larger its mass appears. From this point of view, the famous statement, "as curves spacetime," becomes a vivid picture. Mass is the amount of tightening and combing a knot forces on the energy sea, and curvature is just the pattern of slopes and grooves that tightening creates. You don't need extra invisible forces layered on top. You need to know how the sheet has been pulled. When you think of weight, you can imagine your own body as a cluster of knots pressing the sheet in and tightening it. Your legs tense because they are constantly pushing against the slopped, stretched fabric that the Earth's knot has created. When you think of orbits, you can picture planets as marbles endlessly sliding along the sides of a large basin in the sheet, never climbing out because the basin wall is the path of least resistance. Mass and gravity stop being two separate mysteries and merge into one geometric habit of a single medium. Tap follow, share it on New Physics, Clear Universe.